Right. This chapter is all about trigonometry. It is going to be the first chapter where everything we do, or almost everything we do, is going to be new. There's a lot of new things in this chapter, so you might need to work a little bit harder than you have in the past chapters. Trigonometry just literally means measurement of triangles, and that is originally how trig came to be, was people dealing with triangles. Later on, with the invention of calculus by Newton and Leibniz, trigonometry was expanded to include some things having to do with circles. Today, we're going to talk about radian and degree measurements. We're just covering a few basic things that you may already know, but it's important to review them and get on the same page before we delve into some more advanced things. So a few just very simple things to get us going here. We know an angle. You kind of know what an angle is. We define it as a ray that is rotated. Remember, a ray is just kind of half a line. It starts at a point and goes on forever in one direction. And we have an angle. We have one side that is identified as the terminal side, and one side is identified as the initial side. Technically, in an angle, you should have an arrow indicating what direction you're going. And so then this over here is the initial side of our angle because it's where we're starting, and this over here is the terminal side of our angle because it is where we are ending. If we have a set of coordinate axes, our typical x and y axis, we will generally take the initial side of our angle and put it on the x-axis. And then if our angle is a positive angle, we will rotate in a counterclockwise direction. This is a positive angle. If we have a negative angle, we will rotate in the clockwise direction. All right. We all know that a full circle is 360 degrees, and so from here to here is 180, here to here is 90. Going this way, that would be minus 90. So if, say, I wanted to draw 120 degree angle, well, from here to here is 90. This would be 90 more, so we go a third of that. And this would be a 120 degree angle. 120 degrees. Say I wanted to graph minus 135. Well, I would start at the same place, but then I would go the other direction. And this is 90. This whole thing would be another 90, but 135 is 90 plus 45. So that would be minus 135 degrees. That's how we go about drawing and graphing angles. Angles can also go more than a full circle. Let's say I wanted to graph 470 degrees. Well, a full circle is 360. So we go 360, and then another 90 would be 450, and then 470 is just a little bit more than that. So that would be our 470 degree angle, wrapping all the way around, coming back. Now, this angle is said to be coterminal with another angle, and that is the angle that starts and ends at the same place. Well, 470 minus 360 is 110. So the 470 degree angle is coterminal with a 110 degree angle. We could also add 360. It's also coterminal with an 830 degree angle. We could subtract another 360. It's coterminal with a minus 250 degree angle. So we can keep adding or subtracting multiples of 360 to get angles that are coterminal with one another. A radian is another way of measuring angles. The degrees are one unit of angle measurement, a radian's another unit. A radian is defined as the angle of a circle, the central angle of a circle, where the radius is equal to that arc length. So that's where a radian kind of comes from. A full circle, all the way around a circle, is 2 pi radians. So then, if we go halfway around a circle, that's pi radians. A quarter of the way is pi over 2. This would be, going this way, would be minus pi over 2, and so on and so forth. If I wanted to say, draw an angle that's 5 pi over 2, well, 4 pi over 2 would be 2 pi, which is all the way around once, and then another pi over 2 would be right here. This is 5 pi over 2. If I wanted to find an angle coterminal, 5 pi over 2 is coterminal with, we can say 5 pi over 2 plus 2 pi n, where n is an integer. To find a coterminal angle, we can add 2 pi. We can add 2 pi twice. We can add 2 pi 3 times. We can subtract 2 pi. -1 is an integer. We can subtract 4 pi, and so on and so forth. And that will keep getting us coterminal angles, just like we could keep adding or subtracting 360 to find a coterminal angle. As you know, we know that 90 degrees is kind of the dividing line between acute and obtuse. So keep in mind, acute angles are, the Greek letter theta is an angle that we often, or is a variable that we often use to represent angles. But acute angles are between 0 and 90. And 90 in radian is pi over 2. We know that right angle is 90 degrees, which is pi over 2 radians. We know that an obtuse angle is between 90 and 180 degrees, and that's between pi over 2 and pi radians. For whatever reason, when we're talking about radian angles, we don't include a unit. We just say pi. And it's understood that we're talking about radians. Whereas with degrees, we need to put the little degree symbol up there. I'm not really sure why that is, but it is. And this also kind of motivates our equivalency between radians and degrees. So pi radians is equal to 180 degrees. So if you have a degree measurement and you want to convert to radians, you take the degree measurement and you multiply by pi and divide by 180, and that will get you your measurement in radians. The other way around, if you have a radian measurement, you go times 180 over pi to get your degree measurement. So if I wanted to convert, say, 45 degrees to radians, I would take 45 times pi over 180. And 45 over 180 reduces down to 1 over 4, so 45 degrees is pi over 4 radians. Say I wanted to convert minus 5 pi over 12 radians into degrees. I would multiply by 180, divide by pi. Notice the pi's cancel out. And we can reduce this down. 6, 90, 45, 3, and 3 goes into 45 15 times. So we just have minus 5 times 15, this would be minus 75 degrees. So it's a simple matter to convert between the two units. Now, even though converting is a simple matter, I'm going to want you to be able to kind of think in radian. It'll make doing a lot of things that we're going to do much easier. So I would encourage you, in fact not encourage you, I'm going to require you to memorize, this is 0, pi over 2, pi, 3 pi over 2, and these go with pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, 0 is 0, and also pi over 4 is 45 degrees, pi over 6 is 30 degrees, and pi over 3 is 60 degrees. And I want you to memorize these 5, 6, 1, 2, 3, 4, 5, 6, 7. And also 8. 2 pi is 360 degrees. I want you to memorize these 8 degree radian equivalencies.